Hello, hello. Welcome to another episode of my design stream, and let's get to work because I don't want to talk so much as in the past today. Power entry block is our task for today. Schematic review is the next step. It means I have to go through the entire schematic, check if all components or symbols are or were taken from my library, then to verify the circuits, the schematic, if something is not missing, something obvious. Then I will export netlist and schematic file for an independent reviewer BV circuit. So I will show you how to use it or how I use it. Anyway, let's get to work. So I am going to open the reference design, which is this one. It reminds me that the best way would be to place a link to that file here in the schematic. So one click would immediately open the circuit, but yeah, you know me, I'm not so clever sometimes, most of the time. So power entry, which is the block that contains USB-C. Here is the eFuse, and this is it. So the output is a VBus, which is eFused to with some current limit by exporting in the terminology of software engineering 5V_V in, and 5V_V in is then used for instance for the PMIC and for this buck converter for 3.3, which is the systemic 3.3, not the PMU, but or MPU. But here is the where is I lost here. So bus powered, and the sheet is named probably USB-C 2. Bus powered. So let's open the imported file. Yes, here it is, as before. So yes, now there is, unfortunately this table looks really messy. Okay, I will make a screenshot or yeah, here it is, and in the project folder, which is, where are you? Here? Oh, directly here. Okay, fix. And here is VBus table, will be imported in a while to the schematic. Okay, so this is what we want to import, and power entry is here. Yes, this perfect. This will be power entry 5. I usually you might notice that when I create this labels for the the stamp or for this field, I always create the text with the default text size, save it, or OK, press the OK, click the OK, and then I edit the properties by changing the text size to 5. The reason is that I don't know if this, but previous versions of KiCad remembered your last entered value. So if you changed the size to 5 and then continue with signal labels, everything was fine, and then I have to manually edit back to 1.27, which was like one step more, and sometimes I had to repeat the editing to 1.27. So yeah, this is why I learned this. Maybe it's useless now, but probably I should learn or unlearn what I've learned, but yeah, it's so many things to do. We have some comments. Hello, Salim. Hello. Thank you for being here. If you're still here. Hello, Cesar. Thank you. Thank you for your message. Yeah, KiCad is more and more powerful, and yeah, sometimes I would prefer to slow the development, the KiCad development a little, and focus on important things that are missing in the tools that would really help my work. For instance, filtering when selecting footprints for the symbols, but probably software engineers of KiCad don't know that we need it. This is probably something that I would ask for on some forum, but I am pretty sure I would receive the command that I would create some gate pull request or some things that I don't understand. So yeah, I am anyway. Yeah, thank you, Salim, thank you, and this is something that is in the stars, but I will do my best to succeed in this area with this project. So USB Type-C, some caps, ESD, protection, incorrectly connected shield, again, ESD protection for the USB lines, the comes through or goes through ESD. I think I had this one somewhere else. ESD again. Some pull down resistors. $47K here. 47K. 1.K. 2 and 47. Okay. Okay. It seems that it creates some voltage divider. Probably the table is here for this reason. Okay. Okay. Because this is the USB Type-C, USB 2.0, I will be using, or I will use, probably slightly different footprint, because you can see it's full USB Type-C with all the signals, and we don't need it. So USB-C 2.0 would be would be much easier. For instance, here, because basically, as you can see, we need only CC1, CC2, and D plus, D minus. All the TX, RX are not connected, including the sideband transfer signals. So why to use expensive and difficult to solder because of the fine pitch connector when you can use very simple and easy to solder one. This must be thicker, and we need the yes, review from the last time. I'm looking for this. This is the USB, the ESD for this, so we don't need it. I'm looking for this block. Yes. Yeah, I can see I was wrong with SBU. SBU is still here, but not the TX and RX ones. Yes, this is better. Okay, so ground directly to ground because this is signal ground, and shield is the chassis of the connector. So it has to be isolated through this EMC filter because yeah, it has. So yeah, the ESD protection at eBus, okay, and USB-C. Yes. Yes. This is the ESD. I think this is it. Yes. This is the through. Go through, but we need only 2 signals. Yes. Yeah. The fact that we already have used this air clamp 0524 in the schematic, it means that you can reuse it here. Yes, and here will be DP90 net class, which is already here. Okay, DP90. So this is USB, how they call it, USB-C CC1. USB-C CC1, okay, I will keep the same label and assign the net class of this. Yes. This is CC2, okay, and obviously USB without C, but C is underscore C, okay, there is some inconsistency, but I will keep the same labels because it would make the debugging easier. Yeah, always be careful when assigning this minus plus signals, because as you can see, this connector has plus on the top and my connector has plus on the bottom, so it's easy to switch them, and the result is usually catastrophic. So 02, okay, 0402 as well, and here 0402, and the ESD protection is over here. And 10 nanofarads in 0402 as well. Okay, okay. So 1K2. Yeah, I have to create new component, because I have only different values in my database. So 1K2, which should be this, but we need to verify all the time, DigiKey and GLC-PCB parts. So yes, it works. So yes, and this one. GLC-PCB, so 1.2 kilo ohms, 0402. 1%, yes, this is my resistor. By the way, this is 100 ppm and this one is 100 ppm, so that's the same resistor. Okay, perfect. So we need two units, two pieces. Slightly further. Especially the designator, because you can imagine there will be like R125 and we don't need to interfere with the symbol. What's on the CC? Nothing, just the hierarchical labels. Do we need hierarchical labels? No, we don't. So I will use only the global labels. USB, no. Yes, I need this because I want to change to global. Where are you? Change to global label. Here, and CC have 3K9. Most likely I don't have such a resistor. Okay, I have, but this one 1%. Okay, I don't want to create new ones, so yes, you are 100% correct. No. CC can't be routed as differential pair. You are correct. I am going to remove that class. Thank you for watching carefully. Yes. So 3K9. And they say there is 47K and 100 nanofarads. Okay. So 47K. Yes. CC1, yes. This is CC2. Both will be again global labels. Yes. Here will be some ground connections. Yeah, just a note about new KiCad 9, or I think it's new. I'm not sure now, but I've worked on some video content about KiCad 9, KiCad 10. Here is I think it's quite old, but I haven't used it until now. So this is the button enabling displaying the hidden fields, hidden ports of the symbols. So if it's active, you can see that all the stacked ground signals are here visible, or for instance here. It reminds me that we need to route the VBus with the SD connection on it. So yeah, just a side note. And it means that I have to finish this grounding and work on the ESD protection of the VBus. So I will create more space. Yes. VBus, just VBus and two capacitors. This is 0.8 and this is 0.4. Okay. I will keep it. Already placed. Okay. Yeah, I will use bigger one because I don't have 0.805 in my database, and I think it's not a big deal. There is usually enough space around the USBs because the crowded areas are usually in the center of the board where the highly integrated components are placed. This USB connector is not this sensitive, and yeah, I will use the bigger capacitor here as well. And the ESD protection, I can't forget. So this is the small one I'm using frequently, and what did they use? This one, what's the package? Yeah, the similar one. No, 1610 is the bigger one. Voltage reverse 22 standoff. Okay. It's quite high value. Yeah, 25 nominal. Mm-hmm. Yes. Voltage breakdown about 25. That's quite a lot. Okay, why? The capacitors are rated to 25 and 50, yes. Strange. I have similar ones, for instance, this one. which is 240 in 0402. No, this is pumping voltage is 40, and in this case, yeah, 41. Yeah, that's very similar one. Okay, so I'll use this one. Okay. I'm not here to reinvent the wheel, so definitely not in this first iteration of the design. I will adapt it and we can change it anytime. VBus. VBus is local. Yeah, VBus is local because it's directly connected here. So VBus, and we have to continue with the buck. No buck, the eFuse. I think I have created the symbol before. If not, yeah, I did. So (47) 100 micro in 1210. Two pieces. Here is obviously something smaller, and here as well. Okay, so let's check first. What's the current limit? Let's just verify what they've done. So I limit, current limit. Okay, important. Yeah. Okay. Okay. Current limit with 50 ohm is short circuit 1.1 and overload current 3.2. Please don't ask me what's the difference between overload current limit and short circuit current limit. Probably if you just make a short connection, immediate from a nominal current or zero current to short, it's 1.1. But if you gradually rise the output current, you can overload it until 3.2. Probably. Okay. Okay, 47, 3 point, and the CDVDT. Yeah, I think it's not a big deal to use the same. I don't know if I have such a capacitor. I think I don't. Yeah, I have. Perfect. What I need to do is to change Valsin. Okay, not zero. Okay, can be used. So this one, DK and JL, and we are looking for this is our cap, and it's X7R. Yes, that's it. So the DVDT is set by this capacitor. They say enable is not used. Here is the VBus. Here is the current limit going to output. Am I right? Yes. Am I right? I am right. I'm correct. 47R, which is this one, but needs to be improved as well. 1%. Definitely not this. Yes. So 47 ohm. 75 for 1%. I can't see a difference between these two. Oh, this is 5%, correct. So this one, and the Ageo code is here. So, oh, it's different because it's 0. Okay, it's different package. 47 on stock, 1%, and you know that I love Ageo. Yes. $47. Yes, everything is correct. Slightly here. Oh. And now the caps. These ones can be, but must be junk to review. Okay, later. Okay, let's check the stock and availability. General, yeah, fine. That's good. Rather expensive, but X5R, it's not something that would be exceptionally good. Yeah, they use the same one, same material. And they use this Samsung for lower voltage. Just for my, yeah, this is the Samsung as well. Just for my interest, what's the price? Yeah, half the price. I don't know. This is the similar one in Murata. Nothing on stock. Okay, so I will use my one. My capacitor. At least microfarads, 10 volts, 1210. At least at the moment, I will, yeah, this is it. I will improve this, and the data sheet is not here, here. X5R, okay, and I decided that I will the price impact is there are two. 1 euro is the difference. Fuck it, I will use my capacitors for a slightly higher price. Maybe I have some on my stock. Yes, and then 0 ohm resistor, in this case this one, and test point. Test point here, this is 5 volt. And the output as well. And we said that there is the global label. Here. Hi Pavel, thank you, appreciate it. Have a lovely day. Yeah, we are the best. I'm not the best, but you and the other ones, including me, we all are the best. Thank you. Six to 60 volt, 8 amp, reverse current protection. I think in this high input voltage range and rather significantly high output current, I don't think that you can get the combined device. I think you should use the reverse current protection like the ideal diode controller with external transistor, with external FET, and the eFuse. Let me check my database. Yeah, here is, for instance, the eFuse with the needed input voltage, but yeah, there is no reverse current protection. So I would recommend this. I have used multiple times. So LM5069 as the eFuse, and then I recommend this reverse current protection, or maybe this is slightly easier to solder and easier to manage component. So both are verified solutions. So this as a reverse current protection, LM74700, and this device as the eFuse. I'm sorry, I am not aware of the combined solution, but yeah, check it and you'll see. No problem. Yeah, there are zillions of similar components on the distributor, but there is no point of showing you something from the database of the distributor, for instance, DigiKey. So I'm recommending now what I have used, verified, and what is working. So yeah, these two capacitors, components. Great. So this is our power entry. So we have to place the picture of the table. Pics here. This is the table. Scale 1.25, maybe, yes, slightly bigger. Okay, so we have USB connector, USB to 0, but USB type C shape. So less pads, easier to solder. D minus, differential pair, D plus, differential pair through the ESD protection. Then there is a combination of 1K2 in series, 3K9 to the ground, and then 47 in series with, oh, I made a mistake. This is 10 nanofarads, not 100. Okay. Okay, we have to change it. 10 nanofarads in this case. No, I have used 04010 in the past, but do we need such a small? Probably not. Recently used. Okay, I will use the bigger ones, and in the hardware or schematic review, the part of it will be the bomb check. So if there are only one line with the 10 nanofarads, I will change it to the smaller, or maybe higher and maybe bigger. Okay, thank you. So I can understand that here LinkedIn user is Benny. Yeah. Sometimes the name of the user who commented is not displayed correctly. So yeah, thank you, Benny. Okay, the power entry seems to be done. What about the enable or fault? Can we leave it floating? Please give me a sec. I have to finish something. Okay, let's get back to work. So I can close these data sheets. And yes, I said if we can left floating the enable input. So let's check it. Enable tri-state bidirectional interface. During normal operation, the pin must be left floating, or it can be used to disable the output of the device by pulling it to ground. Okay. So I will place a test point on it, because in the case of some emergency or debugging issues, we can solder the wire on it with ease. So this is still floating, but accessible for debugging. Perfect. So I think power entry is done. Then the schematic review. We are 45 for almost 50 minutes in the show. Let me make a short service break, and I will be here in a while, and it gives me an idea. If you want to support me, if you like what I'm doing, please check these two. Last year, and at the end of 2024, which is not important, I created this course, KiCad for Beginners, which is available at fedevel.com, and this is for complete KiCad beginners. You will learn KiCad essentials in about 3-hour course. You will focus on this small voltage power supply, switch mode power supply. You will learn how to create symbols, footprints, work with 3D models, capture schematics, lay out the PCB, export manufacturing data. Everything is there for your start. If you are moving from another system, I recommend giving it a try, because it will save you a lot of time. And there is a special offer. If you enroll the course, you will receive within 30 days the coupon that you can redeem at nextpcb.com, and you will receive, if you finish the board, you will receive the PCB-A for free, not the bare PCB, the PCB with components soldered. The same for this, for makers, which is slightly more advanced course, but don't be scared. It's not rocket science. There is dual core MCU, 2 USB Type-C, M2 connector, 2 power supplies, bunch of inputs, outputs, everything is there. But the same is, as I said, for the next PCB. There is an offer. If you enroll the course, you will receive the coupon, and you will get the PCB-A for free. And in this case, the average value is about $100 plus. And when you can check the price of the course, which is 69 euros, which is like $75, you will pay for it. You will learn something, I hope a lot, and then you will receive the value in the PCB. So it's like you ordered your PCB, but you will learn a lot. Please give me a while. I am back in a minute. Thank you for your patience. I'm back. So, schematic review. Peripherals must be reviewed until, since the last time. So we have the button bus with 4 buttons, negative reset, button temp, and user 1 and user 2 buttons. There is a slightly different topology. User buttons have the normal low value, while both button temp and reset, negative reset, has obviously the normal high value. So user low, reset high, and button temp high. Okay, everything goes to the user temp, but the reset is a global label. Then there is a boot mode selector containing 2 dip switches. I used the 4-pole one, ESD. Every signal boot 1, boot 0, 1, 2, 3 are pulled up to VDD IO. I added ESD protection because it was missing. Here is a table describing the meaning of the combinations. And then there are 4 LEDs connected to the LED bus. 3 of them in the original schematic are driven from the N-MOSFET, N-channel MOSFET, and the red one is connected directly to the signal. So I changed it that all of them are driven by the NMOS driver. So yeah, that's it. I think it's reviewed. Power entry was done at the moment. So now I'm checking the status. The PMIC. Yeah. Digital signals, here is the button, is the protection again. They used 10 nanofarad, I have 100, so I will change it. And that's the 10 nanofarad again. But yeah, there is a question. Let's finish the 10 nanofarad issue. Let's generate the bill of material, which will contain here. Oh, okay, I know. The issue is that it's mixed with the original imported schematics. Oh, which is not convenient, and plus the schematic is not ready, not completely ready. Okay, so for now I will change to 1 nanofarad 0603 as I used on the power entry, and if it doesn't work, it means if the BOM will tell me that I'm doing a bad job, I will change it. Okay. Yeah, I clearly remember that I use the same components. Yes, even the inductors of the same package. Yes, the description is the same. Yeah, I think the yellow LED directly from GPIO 3. Yes. Yeah, and external enable 1.5 is this, because the PMIC controls the eFuse, the buck converter for 3.3. Yes. Okay. Yeah, at best I would set this as unpopulated and yeah, like exclude from everything, or at least at this moment exclude from the bill of materials, but I can't do it for the entire schematic. This is what we done before. Yes, it looks good. Yeah, I think. Mm-hmm. Yeah, I believe it's okay, it's correct. Yeah, I can delete it. SD card, okay, review, fine. Here is the bus for the signals, that's fine. Yeah, the power entry is VDD. Flash or 3.3, which in the original schematic I can clearly remember. I can clearly remember that the original, oh, here it is. The original schematic with SD card, which is here. Yeah, have unpopulated 3.3 0 ohm resistor, so correctly. I omitted this capacitor because there is this bigger one, which is not a big deal, and yeah, it can be there or doesn't matter most of the time. In this case, I added EMC connection, EMC protection for the shielding. I added slightly different EMC protection diodes. I added serial resistors to all of them, not just to clocks. And there are pull-ups for these D2, yes, D3, yes, command, yes, and clocks as well, yes. All 47 clock has clock has 10K, that's correct. And here is the protection for this, yes, because I simplified. Okay, there were 2 channels empty, so I placed the signal through it. If it doesn't work in the face of PCB layout, I will use the discrete component. That's not a big deal. I kept the 0 ohm resistor here, which is not a big deal as well. Yes, so I think it's fine. Can delete it. Peripherals were reviewed a minute ago. Power MPU, which is the block connecting all power entries to the MPU, which is VDD from VDD IO, yes, VDD CPU from VDD CPU, VDD core from VDD core, and VDD DDR, VDDQ DDR from VDDQ, from VDD2 DDR, yes. There is VBAT from the anode O-ring, anode diode O-ring from DDD-IO and battery connector. The VREF plus goes from VDD-A, yes. Yes, 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 VDD 1, 2, 3, 4, 1, 2, 3. 1 from VDD-IO plus 3, and VDD2 is from VDD 1.8. Yes, that's correct. Plus we have VDD 1.8 ADC from VDD 1.8 1V8. We have 1.8 USB from the same. We have 1.8 CSI from the same, 1.8 DDR from the same, VDD 18 AON. 18 AON goes from AON, yes, and VDD 18 PLLs from, yes, that's good, and the grounds are connected, including the VREF, yes, VREF negative. And we have V08 cap. Yes, that's correct. Yes. MPU will be done as the last one. So we have VDD and VDDQ. VDD is supplied from the VDD1 DDR. Yeah, the issue is the issue is this is DDR4 and this is DDR3L. But yeah, I can remember that I have checked it multiple times. Yeah, this is the interconnection from the STM32MP215F DDR helper, and this is part of the default connection because the first 7 bits are systemic. There are these signals and some of these. I think I can remember correctly. The reset doesn't have the pull up or pull down. Okay. Okay, and here is ZQ with pull up. But we have pull down because we have DDR3L. Now let me check it. ZQ. Yes. External reference ball. This ball is tied to an external resistor which is tied to VSSQ. Yes. Yes. I can delete this because it's not applicable to this case, and I think offline I will check the memory connection. Yeah, this is the RMII controller with the bus connection. Yes. Yes, this is the same. Bias 12K1 here. Yeah, and this usual combination, including the ESD. Protection, yes. Yes. Again, the chassis. Connection, yes, speed, okay, I think it's correct. MP, no, not M2 is the last one on the sides here. Review. Yeah, I can remember. There are 2 or 3 voltage translators from 3.3 to 1.8. There is missing ground. And this is the automatic. Bidirectional automatic direction sensing, yes. That's probably good, both of them. And this one is configured as, yes. First 2 channels are connected from A to B, and the other 2 to B to A. So first pair from A to B, and the second one from B to A. That's correct. The M2 connector looks very different, but the package is the same. I added the spacer, solderable spacer, which took me a while until I found it. Yes, I copied the blocks per partes. I can clearly remember. Yes, I believe it's correct. And here are the the buses that are correctly defined. This will cause a lot of warnings, but it works. Yes, I can delete it. Now the modification of the MPU, because here is a lot of, for instance, here. So let's start with the buses. Just a quick check. We have defined the Ethernet 1 with all the signals that must be exported. So you know what? This is global label. No, it's part of the. Oh, it's part of the bus. Okay, okay. So I did wrong. It's part of the bus. Okay. So let's. Clock is the first. MD int. MDIO. MDC. TXD. TXD0. TXD1. TXD enable. RxD1, RxD0. Not enough space. RxD1. CRSDV. Not enough space. And the last one is unreset. Yes. Okay. LCD we don't have, so we can keep it as is. But I don't know if it, I think it will not work. This is correct. No, this is not correct. Because we don't have the LCD block, we don't have defined the LCD labels, so I will create this. Then we have LCDG2. And B. And now yes, USD macro SD. That's what we have. Our bus is called SD. With all these signals. SD. Okay, I will do it this ugly, but we will see that in a while I will correct it. And the next three are CK, CMD, and detect. Okay. Yeah, the same way I can do it here, but yeah, it's already there. These two buses. Button. So I think we have both LED and button. Yes. So the same way as here. This is LED. This is button. LED 1, 2, 3, and 4. And the button. No, this one here. No. Okay, camera, we don't need boot mode. I think we have peripherals, yet the boot bus, so we can do this. But here is not enough space, so we have to make it. The expansion. We don't have the expansion connector, so it will be all unconnected, probably. Or completely removed, because it goes somewhere, but not on the expansion connector. So yes, this is probably here. Nice. And this one. Peripheral I2C. I think I didn't define this. Yes. Peripheral I2C, peripherals. Oh. Peripherals, I square C. Square C2 SDA. It goes to the LCD, to the camera, and to the MPU. Okay, so we don't need it. These signals okay. Now these ones. BT UART, probably from the M2 connector. Yes, these buses. Yes, these buses. So BT UART, I will copy it per partes because to keep it. To keep the consistency and integrity of this because it's a mess. So BT UART here. STM32 here. M2 control. And SAI1. Yes. Nothing more. Okay, the expansion, I think I can remove it because, as I said, the signals are going somewhere. Maybe some of them are unique for the expansion connector, but the ERC check will tell me that the signal goes nowhere, which is good. So I will know that this is something that must be marked as unconnected. Okay, so let's work on these symbols. This test point must be replaced with my symbols here. Does it have a name? No, it doesn't. So I will not change the value, but everything other will be changed. And we will change all the symbols matching this identifier. Perfect. Why just one? Okay. Okay, it's slightly unique. A lot of work with them. These are global labels, I can remember. $200 ohm in 0201. That will be painful. Anyway, what's the CSI RX? Okay, it's like, but CSI, wait. We don't need the CSI. Hello. Typical value is 10K. Okay. Can be left floating. Okay, still thinking. I think I don't need it, but yeah, we don't need it. But what if we do for some reason? For instance, the default firmware or software package will count with it. I don't know. I don't know. Okay. Okay. Mhm. It changed about 5 test points, but I don't know which ones. Okay, these ones. Okay. Which one? MCU2. Can I change all this to my ground symbol? Yes, I think I can. This is global label. Yes, more screwed test points. And when these two resistors can be in 0402, then I believe the resistor for the CSI-RX can be of this size as well, because it's the same package, the same issue, the same size constraints. So power PMIC, all the signals from power PMIC. Yeah, all are global labels. I think I changed the notation. Okay. Yeah, and the said have 10 nanofarads to ground. Where is the unreset? Here is the mistake. It's reset, not interrupt. The size 0402. Yeah, that's the okay. Okay, not enough time today. Not enough time. The schematic review will be done next time. This is header. Okay. Not a big deal, but a lot of small things, as you can see. There should be the protection, definitely, must be. For some reason, the reference design creators ignore the ESD protection. I don't know why. You definitely don't want your design fail because of some sparks on your fingertips. Oh, I don't know. Yes. This is either 127. 2 times 7. I don't need. I don't have in my library probably. 1.27. Doesn't have to be so small. 2 times 10 I have. Yeah, it's better. Oh, that's header, no socket. Header. Yeah, the same one. Yeah, this not the same one, but another one. Through hole. No through hole with the. Yeah. I don't know how to say. The two walls. Okay, next time. Next time, it's a lot of work. Here, 2 crystals. Yeah. I'm sorry, I don't have enough time for today. Okay. So I'm sorry I wasn't able to finish it today. I would like to, but yeah, there's a lot of work with these connectors. Yeah, this is the same type, but smaller. FTSH, maybe there is a standard KiCad library. No, it isn't. Pin header 127, SMT 2x7. Another option is to use the THT ones. Okay, please give me a second. I have to make a short break and I will continue with these headers. So let's crush it. Yes, it's crazy expensive. Crazy expensive. Is it even normal? Yeah. Yeah, we have to find better footprint, and yeah. Yeah, this is always an issue here, but we need in stock pitch through hole, number of pins 14. Into rows, and the pitch is here. Yes. Can be this one. And now the footprint. Vertical. This one. Saving to my library. Because I have to review the 3D model. 3D model is okay. So 2 times 7, 2 times 0.7. This. And 2 times 5, but unshrouded, probably unshrouded. I have only shrouded once. Already exist. Okay. Okay. And the footprint, the 3D model is okay. Fine. So this one. No, this one must be renamed to shrouded. And the new one will be without it. Fine. Now, clear, we have 10. Yeah, the D1 looks good. Now this, just 10. And the datasheet is the same. Okay, so this one, not shrouded, THT. This is this. GLC is this one is 953 at the end. Yes. The datasheet is the AM tag is here, and pin header is this one. Yes. Okay. Not a biggie. Should I mention the SD protection or not? Don't let me start it with it. Now the crystal. This is not as easy as it looks like, because we have to check the load capacitance 6 picofarad. Okay. This one. Nine picofarads. Okay. So we have to make the external capacitors higher. Okay. one. I think it's multi-comp. Indeed. They have smaller one, isn't it? Yeah. They have smaller ones. Load capacitance 6 or 9, better 9. So. Okay. This one can work. And the footprint must be This is 1612. What's the name of the package? The size of the package I've lost. 1612. It's not such a this one. Okay. Good. I by intention used the crystal with higher load capacitance to be able to reuse these molding capacitors. Okay. Okay. Next week, schematic check and schematic review and everything. Thank you for being here. Thank you for watching. I was slow, but yeah, it was more work here than I thought. Thank you for being here. And as I said, if you want to support me, KiCad for beginners at Fedevel, KiCad for makers at the same fedevel.com. Both courses are priced as low as the redeemed coupon you will receive at next PCB will give you all the money back and maybe extra some extra more. So thank you for watching, thank you for supporting me, and see you next week. Yes, next week. Bye bye.